All right, time to go teach. Hello and welcome to this episode of Tutor Tutors, where we continue our unit on ecology. Today we are looking at atmospheric dynamics, looking at some of the different things that are taking place up in the sky above us. So the first thing is we are going to be able to describe the purpose of the ozone layer. So that is our first target of the day. Next is to describe how acid rain is produced, and then we are going to describe the greenhouse effect. What is the greenhouse effect? How does it work? And lastly, explain some effects of anthropogenic CO2. That is CO2 that is produced by us, by humans. So those are our different goals for the day. First, well, what is the purpose of the ozone layer? How does it work out? Well, first thing is to recognize that ozone is O3. It exists as this very interesting molecule where it is not stable. It is very unstable because our oxygen is bonded in this very interesting way, up having basically a half bond between these two outer oxygens. It's not really a double bond between one oxygen and a single bond between the other one. It's more of a shared bond between these outer oxygens with that central oxygen. And the purpose of it is that ozone blocks harmful ultraviolet rays from making its way to the surface of the Earth. That is the purpose of ozone. So as we take our sun and sunlight hits ozone, the ozone molecule will break apart. And that creates this really interesting thing called an oxygen radical. And the thing is, oxygen as an atom does not like to be monatomic. It is not stable as a lone atom. It will bond with something else. It has to. It's not stable on its own. So this, we call it radical, because it's highly reactive, and it will react very quickly back with an oxygen molecule, and we end up with ozone again. And that is a very quick process. But sometimes when that light hits our ozone molecule and we form a radical, our radical will bond with another radical, and we end up with, instead of another molecule of ozone back, we now have two molecules of oxygen gas. And this is one of the ways in which the ozone is not replenished. The ozone is not recycled in this sense. And this is a slower process, which is going to be one of the ways that ozone is going to be leaving the atmosphere. When we look at the depletion of the ozone layer, one of the issues is what happens when chlorine gets involved. And chlorine gas is Cl2. And you'll notice here I just happen to have a single chlorine atom. And the reason for this is as sunlight, hits Cl2, just like how light breaks apart ozone, light will also split the chlorine atoms from each other, and we'll end up with a chlorine radical. This chlorine atom is highly reactive, and it will react with ozone. And how it works is it will actually strip an oxygen away from the ozone, and this forms molecular oxygen. But the chlorine is not done. What's going to now occur is that the chlorine is going to end up being able to react with another molecule of ozone. And now we have formed two more molecules of oxygen and this chlorine radical, which can then destroy more ozone molecules. And that's the issue with chlorine in our atmosphere. It is one of the main ozone depleting substances. ODS stands for ozone depleting substances, and chlorine is one of the main culprits for the destruction of ozone. And that's why we happen to have a thinning of the ozone layer over the poles, because the wind patterns push molecules from the equator towards the poles. And that's why we end up with more chlorine over Antarctica, for example. And the chlorine will then continue this process, taking now another oxygen, forming that molecular oxygen, and thus destroying more molecules of ozone. And that is how the ozone layer works. Acid rain, well, that is going to be typically formed by the burning of fossil fuels for electricity, mainly coal. Because coal, when we burn it, we don't just release carbon dioxide. When we burn our coal, we are typically going to release sulfur dioxide and NOxes. We call it NOxes because it isn't necessarily an NO2 or an NO3. It's a little bit of a mixture of both. And so we just use the X as a variable for that. The sulfur dioxide and the NOxes are going to then interact with the water in the clouds. And when they do, they are going to produce H2SO4, sulfuric acid, and HNO3, that is nitric acid, which is then going to come down in precipitation, reducing the pH, overall pH of our rain, because there is going to be sulfuric acid and nitric acid present within that rain, all because of the sulfur dioxide and the NOxes that were released through that combustion. That is acid rain. And then we get to the greenhouse effect. What is the greenhouse effect? How does it work out? And why are we happy that it exists? First off, we're happy it exists because it allows for this planet to have life on it. Right? The sun's rays are absorbed and reflected by the Earth and its atmosphere. So our sun's rays are going to from the sun hitting the Earth's surface, and then they are going to be reflected back. Now, those rays that are reflected many times are going to be reflected as infrared radiation. Now, that infrared radiation can just escape into space. But if it just escapes into space, that means that we are not going to be able to have any heat upon this planet. This planet would just be a frozen rock because all of the heat would have escaped into space. But thankfully, we happen to have some molecules that are able to absorb those infrared rays. Those molecules we refer to as being IR active or infrared active. Those gases can then absorb those rays, specifically carbon dioxide, methane, and water. Water is actually the most IR active of all of the different molecules within our atmosphere. Water is able to absorb those infrared rays extremely well. In order from strongest IR activity to weakest, they are water, methane, and carbon dioxide. Carbon dioxide is actually the least IR active of these three different molecules, but it's the one that we release in greatest amounts due to industrial or commercial processes. And that's why we pay the most attention to the carbon dioxide in the atmosphere, because we release a lot of it. As these vibrate, they actually re-emit the infrared, they re-emit the heat, keeping the heat around the surface of the Earth. So that way the surface of the Earth is not just a frozen rock, but it has the temperatures that you and I are very familiar with today. But the effects of increasing the amounts of CO2, and specifically the amounts of anthropogenic CO2, the amount of CO2 that we release into the atmosphere, that is causing climate change. Because as we increase the CO2 in the atmosphere, that causes the temperatures to rise, which first off, is going to increase the evaporation rates. And remember that water is the most IR active of all of those different molecules. And so if we increase the evaporation rates, that means we are going to have more water in abundance within our atmosphere. It's also going to change plant metabolism. That's one of the things that we have seen. As we've increased the amount of CO2, that has an impact upon the metabolism of a plant and how they actually undergo the process of photosynthesis. It also causes the oceans to acidify. The oceans absorb that CO2. The CO2 from the atmosphere can be dissolved in some amounts into our oceans. And that's going to produce a carbonic acid, which is then going to decrease the pH of our ocean. And that is going to then harm the organisms that exist within our ocean. And those are all problems with the amounts of CO2 that we happen to be releasing into the atmosphere. So in summary of all this, the ozone layer, it is necessary for all life on Earth. If we don't have protection from the ultraviolet rays, then the sun would just cause so much damage to all of life upon this planet. The ozone layer is critical for life's existence. The greenhouse gases, they're also essential for our survival. If we don't have the greenhouse gases, that means that this planet would not be able to retain any heat and would just be a frozen rock. But we cannot think that we have no impact upon our environment. We cannot think that we have no impact upon the world around us. Increasing the amount of carbon dioxide in the atmosphere is going to cause a change in the climate. And that is something that we as humans are going to have to deal with before too long. On that, be awesome, stay awesome.